Yes. Hello friends, welcome to the session. Continuation of chapter 4, that is measurement of voltage and current. Okay. The last session I discussed about how to convert PMMC as a ammeter and what the concept of multi-range ammeters. Okay. Then the another concept in PMMC instrument, how to convert PMMC as a voltmeter. Okay. That is DC voltmeter. PMMC voltmeter means we are studying about the DC voltmeters. Okay. I told already, directly by using whatever the instrument alone we are using. If you use instrument alone, we can measure the maximum voltage of 100 millivolts only. But by using same meter, then if you want to measure the high voltages, then we go for extension of range. Then how to extend the range of PMMC as a voltmeter? Listen please. Yes. Let this is PMMC instrument representation without any modification. Let this is PMMC meter moment. PMMC meter moment. Yes. The meter resistance is Rm. Yes, meter resistance is Rm. It measures the maximum current of Im. Measure the maximum current of Im. Okay. This is without any modification. And it measures the maximum voltage of Vm. Maximum voltage of Vm. Okay. Then by using same meter, we want to extend the range from Vm to V. By using same meter, we want to extend the range from Vm to V. We want to measure V voltage. Okay. But this V is greater than Vm. V greater than Vm. Yes. If V is increases, Im is also increases. Then to define Im dash, V by Rm. But this is Im dash is greater than Im. But you want to measure this high voltages. Why? If voltage applied across the meter is increases, meter current is increases, then meter will be damaged. Without damaging this meter, we want to measure the voltage of V. Now, for increased voltage, current is increased. The increased current you want to limit. In order to limit that current, we can add in some resistance in the denominator. We want to limit high currents now. We can add high resistance in the denominator. That's why to extend the range from Vm to V, because of this high voltage current is increases, in order to limit that current, a high value of series resistance is connected. This is RSC. A high value of series resistance is connected. Okay. This is Vm, this is V. Now what this voltage you tell me? This voltage is V minus Vm. This voltage is V minus Vm. And then it is nothing but a PMMC as a voltmeter. That means to convert PMMC as a voltmeter, to extend the range of PMMC from Vm to V as a voltmeter, what you can connect? A high value of series resistance is connected. That is one point to remember. Therefore, whenever series resistance is added, then this value is reduces, then it is tends to Im. We are maintaining current is constant, but we are measuring the high voltages. That's why to convert PMMC as a voltmeter, PMMC as a voltmeter. Yes, what you are doing? A high value of yes, series resistance is connected. Series resistance is connected. A high value of series resistance is connected. One more point. A series resistance bypass the high currents or limits the high current? Limits the high current. Yes. A series resistance, yes, a series resistance limits the high currents. Limits the high currents. A series resistance limits a high value of series resistance limits the high currents. Okay. Now the question is, to extend the range from Vm to V, what value of RSC you can connect? That is nothing but a design of PMMC as a voltmeter. Actually, it measures the voltage of Vm. Now we can extend the range to V. What value of RSC you can connect? Yes. Here we don't have any parallel branches. Apply the series branch concept. In series branch, current remains same. In series branch, current remains the same means whatever the current is passing through the meter, the same current is passing through the series resistance. That means the current in the meter is Im. The current in the series resistance is also Im because it is a series. Okay. Then how we can write the current in the meter current equal to Vm by Rm. Then what is the current in the RSC is also same. How we can write V minus Vm by RSC. Okay. Then from this, tell me what is RSC by Rm equal to? Yes, RSC by Rm equal to V by Vm minus 1. Then what is RSC equal to? This Rm into M minus 1. To extend the range from Vm to V, what value of RSC you can connect? RSC equal to Rm into M minus 1. This is important. Then what is M here? M equal to V by Vm. This is called multiplying power or multiplying factor. Yes. Multiplying power or multiplying factor. Multiplying factor. Okay. This is the value of series resistance to extend the range from Vm to V. That RSC equal to Rm into M minus 1. For example, to extend the range from V equal to 10 times of Vm. To extend the range from, for example, if V equal 10 times of Vm, then how much series resistance we can connect? V equal to 10 times of Vm means what is V by Vm? This is 10. Then what is RSC equal to? This is M equal to 10. Then what is RSC equal to? 9 times of meter resistance. If you want to extend the range 10 times, then you select the then you can select the series resistance is 9 times of the meter resistance. Okay, that is the meaning. That's why to convert PMMC as a voltmeter, a high value of series resistance is connected. That high resistance will limit the high currents. Okay, and this is about what exactly PMMC as a voltmeter. But point to remember, after converting PMMC as a voltmeter, then this total voltmeter, after converting PMMC as a voltmeter, the total input resistance of voltmeter, Then what is the total input resistance of voltmeter? The input resistance of voltmeter is denoted by RV. What is the total input resistance of voltmeter, you tell me? Rm plus Rsc. This is Rm plus Rsc. This is the total input resistance of voltmeter. After converting PMMC as a voltmeter. Practically, this is input resistance of voltmeter. Practically, it is high value. Practically, the input resistance of voltmeter is high value. Then, ideally, the input resistance of voltmeter is infinity. Ideally, what the current taken by the voltmeter? IV is current taken by the voltmeter is 0. Okay. Practically, this value is high, but ideally it is taken as infinity. Then ideally, the current IV is current taken by the voltmeter. What is RV? Input resistance of voltmeter. Throughout analysis, we can follow this notation. That how to make the notation of input resistance of voltmeter is RV. This is RV is the input resistance of voltmeter. Okay. Ideally, input resistance of voltmeter is infinity. Ideally, the current taken by the voltmeter is 0, but practically it is a high value. Practically, the current taken by the voltmeter is less. Okay. This about how to extend the range of PMMC as a voltmeter. But I want to extend this concept, important for competitive. Listen please. If you connect only one series resistance, then we can extend only one range. Then we can extend up to only one range only we can extend. But by using same meter, we want to measure the different ranges of voltages. If you want to measure the different ranges of voltages means, then you can implement which one? Multi-range voltmeters we can implement. Then how to implement this multi-range voltmeters? These multi-range voltmeters are implemented by using two methods. One is using individual series multipliers. Another one is using potential divider arrangement. Now we concentrate on what the individual series multiplier method and what the potential divider arrangement method. Okay, shall we start with then multi-range voltmeter? Concentrate. Yes. This over now. Mainly remember this form, RSC equal to Rm into M minus 1, where M equal to V by Vm, that is multiplying power or multiplying factor. Okay. Yes. About siding, multi-range voltmeters. Yes, listen to this. Multi-range voltmeters. Then how to implement this multi-range voltmeters? Yes, these multi-range voltmeters are implemented by using one is individual series multipliers, by using individual series multipliers method. Series multipliers. Another one is using potential divider arrangement. Using potential divider arrangement. using potential divider arrangement and using individual series. First we will see how to implement using individual series multipliers method. Using individual series multipliers method. Instead of using one series resistance, we can use the different values of series resistance. Let the series resistances are connected like this. Let this is RSC1. Okay. Then this is RSC2. Then this is RSC3. Like this, we are connecting different values of series resistance. Okay, the arrangement is like this. But it is a voltmeter concept. Now it must be in series with meter. It must be in series with meter. Or make the connection like this. This is PMMC meter moment. Then this is meter resistance. RM is the meter resistance. Okay. Then what about this IM? IM is the meter current. This VM is the meter voltage. Okay, this arrangement is nothing but a individual series multipliers method. By seeing the arrangement, you are ready to identify it is a individual shunt multiplier or individual series multipliers. If the resistances are comes in series with meter, then it is a series multiplier method. If it is comes in parallel, then it is a shunt multipliers method. Okay, this position 1, this position 2, this position 3. If the switch at position 1, we are extending the range from V1 to VM to V1. We are extending the range from VM to V1 means, then what is this voltage? V1 minus VM. We are extending the range from VM to V2 means, then what this voltage? V2 minus VM. Yes. We are extending the range from VM to V3 means, then what this voltage? We are extending the range from VM to V3 means this voltage is V3 minus VM. Okay, that is, if the switch at position 1, we are extending the range from VM to V1, then by selecting RSC1. Selecting RSC1. Same concept. We are extending range from VM to V1 means this is V1 minus VM. This is V1 minus VM. This is VM. How to write? VM by RM equal to V1 minus VM by RSC1. That is VM by RM equal to V1 minus VM by RSC. Current remains constant. Then from this, what is RSC equal to? RM into V1 by VM minus 1. What is V1 by VM? This is M1. Then RSC equal to RM into M1 minus 1. RSC equal to RM into M1 minus 1. Then at position 2, if the switch at position 2, then what is the range we are extending? We can extend the range from VM to V2, Vm to V2. Then we can extend the range from Vm to V2. What is M1 here? Tell me. V1 by Vm. We can extend the range from Vm to V2 by connecting RSC2. Okay. Then apply series branch. Here the V2 minus Vm, this is Vm. How to write current? V2 minus Vm by RSC2. Yes, V2 minus Vm by RSC2 is equal to Vm by Rm. Vm by Rm. Then what is RSC2 equal to? Okay, Rm into then RSC2 equal to Rm into M2 minus 1. Yes. Then what is M2 equal to? V2 by Vm. Okay. Similarly, if the switch at position 3, we are extending the range from Vm to V3. We are extending the range from Vm to V3 means V3 minus Vm by RSC3. That is V3 minus Vm by RSC3 is equal to Vm by Rm. Then from this one, what is RSC3 equal to? Rm into M3 minus 1. Like this, what is M3 here? V3 by Vm. Like this we can extend the range. Okay, this about PMMC as a voltmeter using individual series multipliers. But only drawback of this method is it requires different values of series resistances. But during change of switch from one position to another position, there is no damage of meter, all these. But only drawback is it requires more number of different values of series resistance if you measure the different ranges of voltages. Now in order to overcome this drawback, then we go for potential divider arrangement. Instead of using the different values of series resistance, by using one large value of resistance, we can measure the different ranges of voltages. That arrangement is nothing but a potential divider arrangement. Clear? Concentrate. Quick. Over. Then you go for potential divider arrangement. Or the potential divider arrangement. Yes. Concentrate on potential divider arrangement to extend the range. How to extend the range of voltmeters by using how to implement multi-range voltmeters using potential divider arrangement. Okay, instead of using different values of resistance, we can use one large value of resistance. So this arrangement is nothing but a potential divider arrangement. Please change this. You connect one large value of resistance. This is PMMC meter moment. The meter resistance is Rm. Okay. The meter current is always Im. Because it is a series, the current remains same. Okay. Let this voltage is Vm. Let this voltage is V1. Let this voltage is V2. Let this voltage is V3. Okay. Then let this resistance is R1. Let this resistance is R2. Let this resistance is R3. Then this arrangement is nothing but a potential divider arrangement. Okay. Vm voltage with Rm resistance, V1 voltage by adding R1, V2 voltage by adding R2, V3 voltage by adding R3. Now the question is, to extend range from Vm to V1, how much R1 you can connect? Before that, the current remains same. Then what is Im equal to Vm by Rm? Yes, Im equal to Vm by Rm. Tell me. The first design is to extend the range from Vm to V1. How much value of R1 is selected? Then how to write V1 equal to, from this you tell me, V1 equal to, this is series na, current remains same. Whatever the current is passing through the meter, here also same current. Then what is V1 you tell me? This voltage I want. Rm plus R1 into Im. Shall you write like this? R1 plus, yes, Rm into Im. Okay. From this, what is R1 plus Rm you tell me? R1 plus Rm equal to, yes, V1 by Im. That is V1 by, how to write Im? Vm by Rm. Then what is R1 plus Rm equal to? R1 plus Rm equal to M1 into V1. Yes, M1 into Rm. It's correct. Why I am writing like this? What is V1 by Vm? This V1 by Vm is M1. This goes into the numerator. M1 into Rm. Then from this, what is R1 equal to? Take Rm is common. M1 minus 1. This is the design of R1. Then what is M1 equal to? Yes, V1 by Vm. Okay. To extend the range from Vm to V1, this much of R1 is selected. Similarly, if you want to extend the range from Vm to V2, to extend the range from Vm to V2, what value of R2 you are selecting. Then for this you write the expression for V2. How to write V2 you tell me? V2 equal to R2 plus R1 plus Rm into current is Im. Then V2 equal to yes R2 plus R1 plus Rm into Im. Okay. Then from this how to write R2 plus R1 plus Rm equal to yes V2 by Im. V2 by Im. Then how to write this is V2 by Im is written as Vm by Rm. This V2 by Vm is M2. Then what is R2 plus R1 plus Rm equal to M2 into Rm. Yes, M2 into Rm. Then from this how to write R2 plus Rm. What is R1 you tell me? Rm into M1 minus 1. To get standard formula that I am writing like this. M2 into Rm. Then you simplify this. What is R2 plus Rm plus M1 into Rm minus Rm is equal to M2 into Rm. Minus Rm plus Rm cancel. What is R2 equal to Rm into M2 minus M1. This is a design of R2. Like this we can design the R2. Then similarly, to extend the range from Vm to V3, to extend the range from Vm to V3, what value of R3 we can design? Okay, then V3 means R3 plus R2 plus R1 plus Rm into Im. Current remains same. That is V3 equal to yes R3 plus R2 plus R1 plus Rm into Im. So okay. Then from this, what is R3 plus R2 plus R1 plus Rm equal to yes V3 by Im. Then how to write Im? Vm by Rm. This is V3 by Vm by Rm. Then R3 plus R2 plus R1 plus Rm equal to this is M3 into Rm. M3 into Rm. Clear? Then what is R2? This is R3 plus R2 plus R1 plus Rm. That is equal to V3 by Im. That is M3 into Rm. But you want to calculate which one? You want to calculate R3. Then you can design the R3. Yes. You write R3 plus what is R2? Rm into M2 minus M1. What is R1? R1 into M1 minus 1 plus Rm equal to M3 into Rm. Yes. That is R3 plus M2 into Rm minus M1 into Rm plus M1 into this is Rm na plus M1 into Rm minus Rm plus Rm is equal to M3 into Rm. It's correct. Minus M1 Rm plus M1 Rm minus Rm plus Rm is cancelled. Then what is R3 equal to Rm into M3 minus M2. This is the design of R3. That means by using this potential divider arrangement, R1 equal to Rm into M1 minus 1, R2 equal to Rm into M2 minus M1, R3 equal to Rm into M3 minus M2. M3 minus M2. Now you tell me. Then the final summary I am writing here. Therefore, in potential divider arrangement, R1 equal to Rm into M1 minus 1. Then what is R2 equal to Rm into M2 minus M1? Yes. What is R3 equal to? Tell me. Rm into M3 minus M2. Then what is R4 equal to? Rm into M4 minus M3. But I want generalized formula. We want generalized formula and so on. Then how to write Rn, you tell me? Rn equal to Rm into S Mn minus 1. Instead of remembering all this, you remember generalized formula where n equal to 1, 2, 3 and so on, and m naught equal to 1. Then only this formula is applicable. You don't have any defining m naught value. You take m naught equal to n equal to 1, you substitute na r1 equal to rm into m1 minus m naught you can get. But if you take m naught equal to 1 only, then only you can get this formula. That's why in this formula you substitute m naught equal to 1, then remaining formulas you can get. That r1, if you want r2 means n equal to, you substitute r2 equal to rm into m2 minus m1. If you want r3 means n equal to 3, you substitute rm into m3 minus m2. Like this we can. This is the design of potential divider arrangement. Like this, by using individual series multipliers, we are implementing voltmeters. By using potential divider arrangement also, we can implement voltmeters. The drawback of individual series multipliers is it requires more number of series resistances. That's the reason why we are using potential divider arrangement. This is a final summary in potential divider arrangement. Okay, this about how to convert PMMC as a voltmeter and what is the concept of multi-range voltmeters. Okay. Then in voltmeters, one important concept is in voltmeters, with respect to voltmeters, one important concept is I want to define what the sensitivity of PMMC voltmeter or DC voltmeter or DC sensitivity. That is a very important concept. How to define the sensitivity? Put siding. Yes. Sensitivity. That is a sensitivity of PMMC voltmeter. Sensitivity of PMMC voltmeter. PMMC voltmeter. That is DC voltmeter. Or it is also called DC sensitivity. DC sensitivity. DC sensitivity or figure of merit of DC voltmeter. DC voltmeter. Okay. Figure of merit of DC. Sensitivity of PMMC voltmeter or DC sensitivity or figure of merit of DC voltmeter. Okay. The DC sensitivity or sensitivity of PMMC voltmeter is denoted by SV or SDC. SV or SDC. The fundamental formula for SV or SDC is 1 by full scale deflection is nothing but a sensitivity. Even small full scale deflection is also detected, then it is having high sensitivity. That is the meaning. That's why even small value is detected, then it is high sensitivity. That's why we are defining 1 by full scale deflection current. It is also equal to 1 by M. Then it is also equal to Vm by Rm. Then it is also equal to Rm by Vm. Okay. This is the sensitivity of PMMC voltmeter or DC. In general, DC sensitivity means you take that is the sensitivity of PMMC voltmeter. Again, no need to tell every time PMMC voltmeter sensitivity like that. If it is a DC sensitivity means that is the sensitivity of PMMC voltmeter. Then what is the units of voltmeter? Units of DC sensitivity. Units of DC sensitivity. The units of DC sensitivities, this is ohm, this is volt. That is ohm per volt. Ohm per volt. The units of DC sensitivity is ohm per volt. That is ohm per volt. Ohm per volt you can write. Or the sensitivity is also written like this. The sensitivity, the DC sensitivity SV or SDC is equal to, once we are converting as a voltmeter, the total input resistance of voltmeter is RV, then we can measure like this. Then you also write like this. This is also sensitivity. Then what is RV equal to? RM plus RSC. RM plus RSC by V. This also ohm per volt. This is input resistance of voltmeter by total voltage measured. That is RM plus RSC by V. One observation here. If RV is increases, what the sensitivity increases. Therefore, a voltmeter with high input resistance, not only PMMC, any meter. Therefore, a voltmeter with high input resistance, a voltmeter with high input resistance, having high sensitivity. Yes, having high sensitivity. This one observation. Not only PMMC, for any meter, any voltmeter it is applicable. A voltmeter with high input resistance having high sensitivity. One more observation. Yes, we know that if RV is increases, the current taken by the voltmeter is reduces. But if RV is increases, what is the sensitivity? By using these two, I am writing one more statement. The voltmeter which operate with less current, the voltmeter is operating by taking the less current. Then that voltmeter is a high power consumption or less power consumption? Less power consumption. That's why a voltmeter with less power consumption having high sensitivity. Yes, a voltmeter with less power consumption having high sensitivity. Yes, having high sensitivity. This observation is also important. High sensitivity. Now with respect to sensitivity, we know that what is the sensitivity? SDC equal to RV by V. Once you know the sensitivity, the input resistance of voltmeter equal to SDC into V or SV into V. You also write like this: RM plus RSC. RM plus RSC equal to SDC into V. Then from this, what is RSC equal to? SDC into V minus RM. Once you know the sensitivity, how to calculate the multiplier resistance? If the sensitivity is known, by using this formula you can calculate the multiplier resistance. But with respect to this concept, just for understanding, I am giving two examples. Example 1. For example, let us consider V1 and V2 is the two voltmeters. Both are same range voltmeter. This also 0 to 100 and this is also 0 to 100 volts voltmeter. Then how to compare the sensitivity of these two voltmeter? But voltmeter 1 is designed with meter resistance equal to 100 ohms, the series resistance equal to 900 ohms. This is a design consideration. But voltmeter 2 is designed with meter resistance is 200 ohms, series resistance is 1800 ohms. It is designed. Okay. Then both are same range of voltmeter. Now you tell me, what is RV1 equal to? RM plus RSC. This equal to 1000 ohms we can get. What is RV2 equal to? Yes, RM plus RSC. This equal to 2000 ohms we can get. Then what is RV2 is greater than RV1? Then SV2 is greater than SV1. Like this we can compare. If same range of voltmeters are given, the voltmeter which is having high input resistance, that voltmeter is high sensitivity. Like this we can compare. Okay, no need to calculate again sensitivity. The voltmeter which is having high input resistance, that voltmeter is high sensitivity, and this comparison is possible only if the same range is given. But example 2. For example, if different ranges are given, V1 is 0 to 100 volts voltmeter and V2 is 0 to 100 volts voltmeter. Okay. Then voltmeter 1 is designed with meter resistance of 100 ohms, series resistance of 900 ohms. Yes. Then voltmeter 2 is designed with meter resistance of 200 ohms and series resistance of 1800 ohms. Like this it is designed. Then what is the input resistance of voltmeter 1? 100 plus 900. 100 plus 900. This how much we can get? 1000 ohms. What is the input resistance of voltmeter 2? 200 plus 1800. Then we can get 2000 ohms. Then RV2 is greater than RV1. But directly we cannot say that SV2 greater than SV1. Why? Because it is a different, it is a different ranges of voltmeter. These are different ranges of volt. It is let us know it is a 0 to 100, it is a 0 to 300. But RV2 greater than RV1, hence SV2 greater than SV2. Like that you don't say. Because different ranges are. If different ranges are given, then we can calculate sensitivity. Sensitivity equal to voltage by resistance by voltage. What is the resistance? Total resistance 1000. 1000 by voltage is 100. 1000 by 100 means what we can get? 10 ohm per volt. Okay. What is the sensitivity of voltmeter 2? Sensitivity of voltmeter 2 is RV2 by V2. Then how much we can get? RV2 is how much? 2000. This is 300. Then 6.6 ohm per volt. 6.6 ohm per volt. Therefore, then which is greater? Therefore, SV1 is greater than SV2. Like this we can compare. That means what is the observation I am giving here? If same range of voltmeters are given, if RV2 greater than RV1, SV2 greater than SV1, like that we can say. If different ranges are given, then don't make if RV2 greater than RV1, directly you cannot say that SV2 greater than SV1. Then how we can say? You calculate sensitivity separately. Sensitivity equal to RV1 by V1. Then how much we can get? 10 ohm per volt. What is the sensitivity SV2 equal to RV2 by V2? How much we can get? 6.6 ohm per volt. Like this we can compare the how to compare the sensitivity if voltmeters are given. These two examples I am explaining. Explain these two examples. Like this we can compare the sensitivity. But note, you remember what I told. Once you know the sensitivity, the input resistance of voltmeter is calculated RV equal to SV into V. Like this you can calculate the sensitivity. Always input resistance is calculated for full scale deflection, not for measured value. Point to remember, always the input resistance is calculated for full scale deflection. You also calculate like this. What is the sensitivity equal to? Ohm per volt. That is what the sensitivity indicates? Ohm per volt means 1 volt indicates this much of resistance. For example, sensitivity equal to 100 ohm per volt. Then what the meaning of this one? 1 volt equal to 100 ohms. That is the meaning. For 1 volt voltage, it offers the resistance of 100 ohms. That is the meaning of sensitivity. Okay. Then if it is full scale deflection is 100 volts. If the full scale deflection is 100 volts means, then what the total input resistance? Then 100 volts equal to 100 into 100. Then how much you can get? 10,000 ohms. That is the total input resistance. Always what the sensitivity indicates, for 1 ohm resistance, for 1 volt, how much resistance is offered? That is indicated the sensitivity of voltmeter. But always input resistance is calculated for full scale deflection. That point also remember. Okay, this is the concept of PMMC as a voltmeter. Then what is the sensitivity of PMMC voltmeter, or it is also called DC sensitivity, or it is a figure of merit of DC voltmeter. Understand? Okay. We'll see in the next session we will continue with another concept with respect to voltmeter, that is nothing but a loading effect due to voltmeter connection. Every meter will cause a loading effect. First we will start with what is the loading effect due to voltmeter connection. Okay, thank you.